So welcome back to the Wild Globalization Project. Today we're talking about wild ecology. We're asking, how is ecology wild? How might the bounties and the risks of the Earth's ecology drive human civilization? And how do humans fit in? So really we're asking, what's going on? How does the world work? Our Wild Globalization Project is wondering if civilization's life world might in fact work like a, quote, black box. In modern physics, this is called a quantum entanglement. So imagine a wild river, but then imagine several divergent rivers crashing and flowing together: an ecology river, a sex, demographics, culture river, a tech river, an economy river, a governance river, a wild wealth river. Each has its own origin and force. Each is carving out canyons, destroying and then building the world back up again. All are wildly over and underflowing at once in a total surging momentum. Rivers are a wild ecology story. They reveal the Earth's watery bounties and her risks. Humans have taken these bounties and changed the natural world. According to the World Wildlife Fund, only a third of the Earth's rivers today are, quote, free-flowing. Why is that? Well, it turns out that humans like to eat. And since agriculture began 8,000 to 9,000 years ago, human numbers have grown from just 2 million to 8 billion. And we're healthier and have more to eat now than ever. So we need lots of water to grow lots more food. Water gets dammed up and diverted in every way possible. Here in Colorado, 80% of our precious water goes to agriculture. Wild, free-flowing rivers are powerful and magnificent, but this human quantum entanglement is even wilder and flowing more freely. The wildest river in the 21st century may be the sacred Jordan River that runs through the Judaic, Christian, and Islamic Holy Lands. Wild because, as we speak, it again marks the flashpoint of ancient religious hatreds, bitter fighting, and unspeakable atrocities, and the risk of global war. In our quantum entangled world, the Jordan is no longer just a river. But then to add to your daydream by the river, wait a minute, there goes a human streaking by and she's riding a kayak. Where did she come from? Or the kayak, or the paddle? So where does that leave us? What do we have to work with? We're observing that humans have evolved from the natural world by virtue of two more or less unconstrained unique abilities. First, we can be smart or not. Nature has given us, and we've worked at it, the ability to think and alter the world around us. Someone did come up with the kayak and the paddle. We bundle these abilities under science and technology. Second, we can love and care for each other and the planet, or not. Humans have the capacity to do good or evil for humanity and planet Earth. We bundle these abilities under our spirituality, or for many, our faith or religious traditions. So we're asking big questions, questions that probe our intelligence and our conscience, like what is globalization? What do we mean by these rivers, these flows? Ecology, sex, demographics, culture, tech, economy, governance, wealth. How can humanity and the Earth survive in this 21st century? What's going on, and what can we or should we do about it? Wild globalization doesn't claim to have simple answers or any answers at all. As tech entrepreneur Yuri Levine suggests, we're just trying to, quote, fall in love with the problem. We're trying to come up with conversations or maybe some healthy arm wrestling that might lead to, let's just say, better critical thinking. Again, our provocative statement is this: humans have not just emerged from the wild, we are wild Homo sapien, and we've spread ourselves over the planet for 250,000 years. The wild is happening right here and now. We're living this quantum entangled set of momentums. To get to the 21st century, we relied on our critical thinking, but really our persistent rethinking. Our project is trying to live it and think it from inside and outside the box, from different angles: ecology, culture, tech, economy, governance, wealth, and somehow think it all at once. How is this entanglement affecting the planet, changing it? But then how are we getting kicked around by it? Like the kayaker, we're launching into these wild, entangled flows of energy that constantly create and build, and at the same time that break down and destroy the orders of life on Earth. So this Wild Ecology YouTube is part of a suite of several Wild Globalization talks. You can go to substack.wildglobalization.com for transcripts, or our website, wildglobalization.com. So what is wild ecology? So to quote an Oglala native war cry, quote, "Warriors sang their brave song, Hokahi, this life will not last forever. Take courage. The earth is all that lasts." Our globalizing life world lives in a wild and violent ecology. Blue, watery planet Earth, glistening, resilient in her solar system, Milky Way galaxy, universal dark home, is carried by uneven momentums of an original Big Bang event. We still live in the Big Bang's hidden energy that sounds like a quiet hiss on radar. This leftover energy was discovered serendipitously in 1965 by two Bell Lab astronomers when they were cleaning bird poop from their radars. As Nassim Taleb's Black Swan describes it, quote, "It took a while for them to figure out that what they were hearing was the trace vibrations of the birth of the universe, the cosmic microwave background radiation," unquote. So where do humans, Homo sapiens, fit in? If Earth's 4.5 billion year history were imagined in a 365-day year, then we've been around for about 250,000 to 500,000 years, or roughly an hour. We're barely a blip on the geologic clock. The Wild Globalization Project considers wild ecology from deep and original, quote, big orders, unquote, which make or can break life on Earth. Energy orders, big climate, supervolcanoes, and dark matter. So first let's talk about Earth's energy orders. Mark Mills and Peter Huber tell the story of energy orders. Quote, "Starting from nothing 4 billion years ago, life somehow contrived to capture high-grade energy from here and there and used it to assemble more life. So successfully, in fact, that life, a very complex form of order, now covers the planet. A second chain reaction of increasing order got started with the dawn of agriculture about 8,000 years ago. Human societies began selectively planting and breeding crops to capture solar energy systematically, and they used the expanding supplies of energy mainly to breed more people who planted more crops. Humanity's total energy consumption doubled about every 5 to 10 centuries, in step with the slowly rising population," unquote. So energy is a big story. To understand Earth's 4 to 5 billion year stream of life, we have to think beyond raw energy itself and think about energy ordering, or the capture and organizing of energy concentrations. We actually live in an energy oasis that continues to gather energy. So what is energy order? Well, in 2003, total US raw energy consumption, so oil, coal, natural gas, nuclear, hydro, wind, solar, and wood, was equal to about 100 thermal quads. A quad is a quadrillion British thermal unit, or BTU. So it's a measure of heat. However, only 6 of those 100 quads actually achieved, quote, highly ordered status that could power our lives and devices. The other 94% was consumed in finding and getting the energy to us. So, in fact, the ordering of energy itself. 21st century Homo sapiens have climbed to the apex of the Earth's energy and food supply chains. But that also means we're almost totally dependent on those supply chains. We survive and thrive, or not, in an energy food chain that works like this. First, Earth's vegetation gathers the sun's energy. Next, plant-eating animals capture about 10% of plant energy. And then humans live on mostly the plant eaters and vegetables. Finally, apex humans convert food energy into intelligent knowledge, or not. Thomas Sowell, the brilliant American economist, sums it up when he observes that, quote, the cave peoples had the same natural resources at their disposal that we have today. And the difference between their standard of living and ours is a difference between the knowledge they could bring to bear on those resources and the knowledge we use today, unquote. So knowledge of energy order, then, is the key. Modern physics' first law of thermodynamics makes clear that energy can neither be created nor destroyed, it can only be transferred, as in the transfer of heat or temperature between systems. Energy can also be reserved, as in the bonds between the hydrogen and carbon atoms of the hydrocarbon molecule. When the atomic bonds are disturbed and broken, heat, energy, is released. The Hubble and Webb space telescopes are watching the ebb and flow and creation of the universe, virtually from the Big Bang. But they're really watching the flow of energy. And if the first law is correct, there's really no more energy available today than at the beginning of the universe. We've just figured out how to exploit nature's order of energy resources. Energy order and efficiency usually improve over time. Modern passenger aircraft are 3 times more efficient than earlier models. But here's a catch. More efficiency means lower cost, so more folks can fly around. Better aircraft have increased energy demand. Our smartphones and laptops are far more efficient than earlier versions. Still, as Mark Mills reminds us, quote, the global information infrastructure, which didn't exist just decades ago, now uses twice as much energy as the entire country of Japan. So energy demand is increasing. In 1990, 70% of people had electricity. Today, and with 3 billion more of us running around, 87% have it. Amazing. But nearly 1 billion folks are still waiting for it. Human energy ordering can always improve. We're still getting 3 times as much energy from burning wood as we are from the new wind and solar techs. So the bottom line is this. Since the Industrial Revolution began in the 1800s, the order and size of civilization has exploded exponentially, from 1 billion to 8 billion people on the planet, all demanding energy. The secret sauce of it all is that we've mobilized high energy technologies into globalizing markets. We can't overlook how it's all powered by the incessant human demand for energy. As the futurist thought leader Alvin Toffler reminds us, quote, the precondition of any civilization, old or new, is energy, unquote. So big climate, ice optimums, wild climatology, solar storms. Let's talk about big climate. James Kroll, who lived from 1821 to 1890, was a 19th century insurance agent, hotel manager, and then museum janitor at Glasgow's Andersonian University in Scotland. Kroll was also a self-educated scientist who thought a lot about big climate. He noticed three changes or oscillations in the Earth's movement as it orbits the Sun. First, Earth's elliptical orbit oscillates in roughly 100,000-year cycles. Second, Earth's axis spin or precession oscillates in 21 to 26,000-year cycles. And finally, the Earth's tilt varies in 41,000-year cycles. Kroll thought that these cycles triggered significant variations in how the Sun's energy is absorbed by Earth's atmosphere, variations that can cause big climate swings, indeed thousands of year swings, including ice ages. Kroll's theory was finally verified in 1976 by the Serbian scientist Milutin Milankovic, and today scientists study the Milankovitch cycles. Big climate has changed wildly over time. The study of climate may be even wilder. Meteorologists track roughly 150 to 200 years of weather data. They're especially concerned about the industrial age's warming greenhouse effect caused by carbon dioxide or CO2 emissions into the atmosphere as humans burn coal, oil, natural gas. And if you skied Colorado the past 50 years, you just know it's warmer. And then there's climate science's other data set, paleoclimatology, or old climate. Paleoclimatologists study prehistoric climate, data from thousands, even millions of years ago. Data that tracks the Milankovitch cycles and the ice ages. From a wider angle view, they're reminding us of the remarkable fact that all of human civilization's 10,000-year climb out of the Stone Age has happened during an, quote, interglacial climate optimum. So the 10 to 15,000 year periods between ice ages, when Earth's climate has warmed and the ice pulls back. So ice ages have been around for at least 2, maybe even 40 million years. And as a 2016 Potsdam Institute for Climate Impact Research describes them, quote, like no other force on the planet, ice ages have shaped the global environment and thereby determined the development of human civilization, unquote. Just 20,000 years ago, the 10,000-foot deep Laurentide ice sheet covered Canada and carved out the Great Lakes. How would 8 billion humans survive or grow enough crops under a new ice age? But wait a minute, it may be getting even wilder. The same Potsdam study suggests that both nature, along with humans burning stuff, may allow the Earth to skip the next ice age. They speculate that, quote, even without human climate change, we would expect the beginning of a new ice age no earlier than in 50,000 years. However, relatively moderate additional human-caused CO2 emissions are already sufficient to postpone the next ice age for another 50,000 years. So we're basically skipping a whole glacial cycle. It is mind-boggling that humankind is able to interfere with a mechanism that shaped the world as we know it, unquote. Wild big climate, indeed. And as it turns out, CO2 or carbon dioxide may not be all bad. CO2 helps us grow lots more food. And as we noticed above, humans need lots more food. Craig Idso of the Center for the Study of Carbon Dioxide and Global Change reminds us how thousands of laboratory and field studies demonstrate that higher levels of CO2 significantly improve crop production. Quote, as the CO2 concentration of the air continues to rise in the future, this positive externality of enhanced crop production will benefit society in the years, decades, and even centuries to come. Healthier plants need less water, so it's good for our wild rivers. The bottom line? CO2 may warm things up, but it also appears that we can grow more food with less water. To be clear, we're not taking sides here. It's clear that climate is a big deal, especially as human emotions and politics gets mixed in. But we're wondering if folks are really reading all the data sets. The climate sciences, it turns out, cover a wide and growing range of sub-disciplines. Climate science is really a quantum entanglement of data and competing knowledge. No single scientist or study has it figured out. Robert Carter, the Australian paleoclimatologist, cites at least 100 climate change subdisciplines, and he observes that after a lifetime of distinguished labor in the field, he can claim expertise in no more than 2 or 3. For perspective here, look at John Garrett's 1 million year snapshot of hominid evolution. Civilization emerges in the Holocene warm period, the vertical green blip in the lower right. The chart's top half tracks the 100th century run from agriculture to industrialization and our 21st century. But also notice the wild temperature changes on the bottom graph, which tracks the last million years. It's wild climate optimums, and wild human civilization, from ice and fire and goats to atomic energy and smartphones in just 10,000 years. But wait, there's also the sun's big climate to consider. We're all excited about solar energy, but the sun is crazy wild. Consider the 1859 Carrington geomagnetic storm of solar radiation that rained over the Earth and was so powerful it took down electric and telegraph services. A Carrington event in today's complex, microprocessed world would destroy satellites, communication and power grids everywhere. So your car, your smartphone, your laptop could all be lost. Bill Murtaugh, director of the Space Weather Prediction Center here in Boulder, Colorado, admitted that, quote, a Carrington-level event could be catastrophic for Earth, and we'll not even get a long enough warning to prepare ourselves, unquote. So next, consider big fire and volcanism. Consider volcanoes, and especially supervolcanoes that randomly dot Earth's landscape, hide under her oceans, and violently threaten life on Earth. The 1980 Mount St. Helens event was the largest in U.S. history, but on the Volcanic Explosivity Index, it's just a fraction of Pinatubo, which was 10 times greater in 1991, or Tambora, 100 times greater in 1815, or America's Yellowstone, which was 1,000 times greater 640,000 years ago. Yes, Yellowstone, the largest known volcano on the planet, just up the road from here. It's at least 2 to 3 million years old, so humans have lived through its violent eruptions. What's a supervolcano eruption like? A supervolcano event ejects cubic miles of volcanic materials like sulfuric gases into the atmosphere. This can then cause volcanic winters, which trigger loss of habitats and the sudden disruption of food supply chains. Famines, to be concise. The 1815 Tambora event may have taken as many as 100,000 Irish and 200,000 Europeans from famine and the ensuing typhus pandemic. The simple wild ecology fact is that 21st century humans living in our global food and energy supply chains and now dependent on fragile technologies, we remain at far wilder risk than we may realize. Finally, energy, climate, and fire are just what we see in the visible light spectrum. Apparently, darkness and, quote, dark matter make up everything else. The Apollo missions revealed stunning images of the Earth from space. What do we see? Most will notice blue, watery Earth suspended in, quote, space. But consider the more elusive background, the vast, really unimaginable reach of the universe itself. The darkness hiding in plain sight. The wildest fact of all may be that apparently that's where most of the universe's stuff, its matter, lives. Vera Rubin, the brilliant 20th century American astrophysicist, devoted a good part of her career convincing her colleagues that dark matter probably makes up most of the physical universe. Quote, astronomers thought they were studying the universe, and now we learn we're just studying the 5 or 10% that is luminous, unquote. So what are our wild ecology takeaways? It appears that the wild universe hides in a dark fullness. Wild ecologies, ice ages, and solar storms also hide in Earth's history, and supervolcanoes hide beneath our feet. Forces are hiding in other times and spaces of the wild globalization landscape. Our YouTube talks that follow track wild culture's demographic reversal. And after America's 9/11 and now Israel's October 7th, we're going to talk about human culture's wild religions. We'll also track wild technologies, Hal the AI guy. We'll dive into the wild economies, stealth or shadow economy, where half the world works outside of government controls. And finally, we'll take on wild governance's massive public debt crisis that's also hiding in plain sight. Trillions of US dollars, Japanese yen, Chinese yuan, and euros that represent promises global governments have no idea how to pay. And as we try to fall in love with the problem, these practical problems, we wonder, quote, how can humanity, or really us folks on the street, living in this wildness, how can we have a conscience or an ethical compass, unquote. So green energy, for example, appears elegant, surely cleaner than fossil fuels. But we're learning that, quote, a single 1,000-pound electric vehicle battery requires digging up 500,000 pounds of raw materials from the earth. Or Siddharth Kara tells us how our lithium battery-powered culture uses cobalt that's mostly dug up by the hands of slave-like artisanal miners in crude open-pit mines of the African Congo. How is that ecological or ethical? Do these facts make us uneasy? Would we have gotten a smartphone if we'd known that? But then, how do we live without our smartphones now? And we'll track how wildly innovating and, quote, hypernatural humans have pushed the natural world into wonderful but also horrific realities. Atomic energy, but also atomic bombs. Marvelous creations of music and art, but our same human race has also produced genocide, holocausts, and ecological disasters. How do we square that? The startling insight here is that our seemingly clever, scientific, and globalizing civilization races ahead of our common sense, our critical thinking, and our rational governance, and tragically ahead of our ethical response. So here's an early takeaway. We underestimate the unconstrained force of this wildness at our own and the Earth's risk. Humans have not just emerged from the wild. We are wild Homo sapien. The wild is happening right here and now. We're living this quantum entangled set of momentums. We're asking how it is affecting the planet, changing it, and how we're getting kicked around by it. Like the kayaker, we're launching into these wild entangled flows of energy that constantly create and build, and at the same time that break down and destroy the orders of life on Earth. So hang on. So if we piqued your interest or your passion or your angst, this Wild Ecology YouTube is just the second in a suite of several introductory Wild Globalization YouTubes. Go to substack.wildglobalization.com for transcripts or our website, wildglobalization.com. Thank you, and we'll see you next time.